an egg-shaped organ. Egg-shaped reproductive organ. Egg, okay. So whenever you see an egg, you remember the testes.
But before not so bad.
Yeah, please, let's not.
That's the best way to remember pathology. It weighs around 25 grams approximately, and the three dimensions is about 5 by 3 by 2 centimeters. 5 by 3 by 2 centimeters. You can hear me? If you can't hear, you can come in front, please.
A verdade ter sido essa box.
This egg-shaped organ, paired organ, is suspended in the through the spermatic cord into the scrotum. Right? It is in the scrotum. That is at birth or immediately after birth. And the testis has few coverings. And the immediate covering is called as what? What is it called? What are the coverings of testes?
We know this. Epi, no. The epi, do you know?
Shit.
Tunica?
Tunic, oh yeah. Vaginalis.
Tunica albuginea.
Okay. We.
And tunica vagina. So there is a vagina in the.
There's all my opponent.
So this tunica vaginalis has two layers. One is which is close to the organ, which is called as the visceral layer. And the outer one, which is called as parietal layer. Parietal layer. These two layers are lined by what is called as the mesothelial cells. The mesothelial cells. But the most important part is what is called as tunica albuginea. It's important because it is thick, it is strong, and it gives a color which is called as a pearly white appearance. Pearly white appearance on the outer surface. So this tunica albuginea, as I already told you, is a fibrous band. It is a fibrous connective tissue. It is so strong that it penetrates the testicular parenchyma and divides the testicular parenchyma into lobules. There are almost around 250 lobules in each of the testes. There are around 250 lobules in each of the testes. So if you take a cross section of a lobule, this is a single lobule. It has an important structure called as the tubules, and these tubules are around 1 to 4 in number in each lobule, and the tubules are called as seminiferous tubules. Seminiferous tubules. So there are 1 to 4 tubules. These individual tubules are lined by cells called as the Sertoli cells. And on top of these Sertoli cells are the active part of sperms or spermatogonia or spermatogenesis. Okay? So Sertoli cells active have the spermatocytic activity. In between the lobules is made up of interstitium, and the most important cell in the interstitium is called as the Leydig cells. The Leydig cells. Along with that, there is blood vessels that constitute the arteries, veins, and the lymphatics. So this is in general about anatomy of one testis. Out of all these, the most important is the Sertoli cell. Why? Why Sertoli cell is important?
Spermatogenesis.
If you have multiple functions, you become important.
Yeah.
The same thing applies here. Sertoli cell has multiple functions because it helps in behaving like a blood vein, or what is called as a testis, or a blood barrier-mechanism. Testes barrier-mechanism. Second, it generates what is called as the germ cells. The germ cells. So once a germ cell is formed, it has to differentiate, it has to mature, and it has to transform. So all this happens in a Sertoli cell. Most important mechanism is differentiation, maturation, and transformation of the germ cells. The germ cells. So let's stop over here for some time.
Differentiation,
And
germ cells,
seminiferous
maturation,
and
as well
Sertoli
as
cells, and go back into the growth morphology of the testes. Before birth, that is during the developmental phase, the testis has not yet reached the scrotum. So initially it develops in the abdomen. So this is the abdomen. The testis is present as a retroperitoneal organ. And as the development happens, it progresses down. And this progressing down towards a normal path is called as the descent of a testis. The descent of a testis. And this great man testis descends because of an hormone called as MIS hormone, that is Mullerian inhibiting substance. Mullerian inhibiting substance. This is the most important hormone responsible for the normal descent of the testis. So, if there is a decrease in this hormone or if the hormone is absent, what happens? The testes get stuck up in any of the places. So either it can get stuck up in the abdomen or it can get stuck up in the inguinal canal. or in the femoral ring, or in the upper part of the scrotum. So these are the common sites where it can get stuck up. And that particular
you can laugh at the poor man.
the undescended testes or the crypt orchidisms. Crypt orchidism. That is the most common congenital abnormality of the testes. Crypt orchidism. The most common site is the upper scrotum. Almost 80% are found in the scrotum, and as it ascends up, the frequency falls down. Remember, most common site is the upper scrotum. As I told you, undescended testes is when the testes get stuck up in its normal path. But if I find a testes away from the normal pathway, it is called as an ectopic testis. An ectopic testis. So that is the second congenital abnormality. Others are called as anopia and polyopia. What is anopia? Absence of the testicular parameter. Polyopia is when there are multiple testes. Both are abnormal and rare.
Yeah, ANOCHIA.
Let's get back to pituitary testes. So if the testes is stuck up in any one of these sites, what will happen to the function of the testes?
It will be inhibited because
It is impaired.
Yeah.
Second is
impaired
might be absent. There might be no function of the testes.
temperature
When there is
regulation
no
and all
function
that.
of the testes, what will happen to the parenchyma? It undergoes atrophy. So atrophy is the most common complication, followed by which it can cause an obstruction in the inguinal canal, resulting in a hernia, or the testes can twist along the axis, resulting in a torsion. So these are the common complications. These happen, you can still treat it. But the most dreadful complication is it has high chances of malignancy. It has a high chances of malignancies. As high as 50 to 60% of crypt orchid testes can become malignant. And the most common malignancy arising from an undescended testis is a is a seminoma. Seminoma is the most common germ cell testicular tumor. Seminomas. Any doubts? So how do you prevent it? Or how do you identify it? How do you diagnose it? Go on feeling the testes.
Yeah. You unstuck it
Do a
up.
scan. Do a scan. Before the scan, you need to palpate. So palpation plays a role in cryptography. And majority of the cases are picked up in less than 2 years of age. Diagnosis is by doing an ultrasound, a CT, an MRI, and once you identify a cryptography testis, what do? You open the site where it is obstructed and pull it down into the throat. That is called as orthoflexy. Flexy is fixation of the testis. Orthoflexy. So you should know what is cryptography testis. These are the sites where it gets obstructed. What are the complications? And the most dreadful complication is a seminoma, a malignancy, a germ cell. So these are the congenital abnormalities. Any doubts?
Me now time for 90 something slide.
Malignancy, as I told you, it is usually picked up in less than 2 years of age. But if you miss it, every 6 months or yearly, the percentage of malignancy, the chances of becoming malignant increases almost 10 times more. So that's why you need to fix it as early as possible. As early as there's a limit, and that is 2 years. Okay, next is about testicular tumors. In testicular tumors, you go back to this diagram here. So, testicular tumors are classified into germ cell and non-germ cell tumors. So, germ cells, non-germ cells are mainly the fertility cells and the lady cells. These are very rare, around 3% and around 2% of the testicular tumors. Germ cell tumors constitute around 95%. So, further, germ cells are classified into 2 types, that is seminomas. Seminoma which arises from a single cell. Or it can arise from a multiple cells. When it's multiple, you call it as embryonal. Embryonal cell can further be subdivided into somatic and extra. So tumor arising from the embryonal cell is called as embryon carcinoma. Tumor arising from the extraembryonal further classified into yolk sac and choriocarcinoma. Somatic I'm still in the first PowerPoint. So seminoma constitutes around 45% to 50%. Embryonal constitutes around 40%. And the remaining is 3 and 2% like outside. Choriocarcinomas are very rare. Tumors, choriocarcinomas. So this is how you classify the testicular tumors. Remember, the most common testicular tumor is a germ cell tumor, and that is from a single cell somaticus. So, few pictures here. So, those are the seminiferous tubules, and then the empty spaces, the white spaces, are usually filled up with the sperms, the active sperms, and that sperm is identified by a microscope based on its degree of development. It can be spermatids, spermatogonias, and spermatozoas. So that's the normal descent of a testis. That's where it goes. The bilateral in 1/3 of cases. As I told you, majority of the cases is because of hormonal dysregulation of MIs, that is Mullerian inhibiting substance. So these are all the complications. So now let's discuss in detail about all these tumors. I'll be happy if you say no. I can go. Okay, let's make a chart. Make it simple. Done with this. As students, everything needs to be simplified. That's why I'm here. When I make things complicated, you need to remind me. Remind me to know the basics. Okay. So let's start with individual tumors again, seminoma. Which are the other ones? Other types of testis. Just stick to the classification which I did. Yolk sac is also called as endodermal sinus tumors. Endodermal sinus tumor. So in your question, if you get it as an endodermal sinus tumor, or you get an option as an endodermal sinus tumor, it is nothing but a yolk sac. Others? So here you break it out into one is the frequency. That is the percentage of occurrence in a testicular tumor. Second is the age group. Third, morphology, that is gross and microscopy. And then tumor markers. And then the prognosis. Yeah. So which is the most common? Almost around 45 to 50% of that. So this is the most common germ cell. age group. Seminomas are seen in an age group of after 30 or after 30 years. Majority are picked up at 35 years, that is what the research says, but you keep it at more than 30 years. On gross, the seminoma looks like this. It is well circumscribed. It is a bulging tumor. It bulges out. As you cut it, it bulges. That is because of the tumor constituent itself. Second, it is divided into lobules. You can see those septations in between the parenchyma. The grooves. Can you make out the grooves? Can't make out? See properly. It has to be there. Okay, I'll use the point. These are the grooves. Remember, I won't be coming and sitting next to you in a PDP exam pointing questions. So majority are homogeneous, bulging and lobulated tumors. One more thing which you have to notice is it is homogeneous. Homogeneous because there is no hemorrhage, there is no necrosis. If there is hemorrhage, you can see the change in the color. If there is necrosis, you can see the change in the constituents of the parenchyma. It appears like a smooth surface. But one thing you need to know is if there is hemorrhage and necrosis, it indicates that the patient has undergone therapy because it is the most radiosensitive testicular tumor out of all these. So on gross it is bulging, homogeneous and lobulated tumor without any hemorrhage and necrosis. On microscopy, these seminomas are made up of sheets of seminoma cells. Seminoma cells have important characteristics. That is, they are uniform. That is, all seminoma cells appear uniform in size and shape. There is no variation. So pleomorphism is very rare. Second important thing is, if you make out, you can see a lot of clear cytoplasm. Can you make out? Yes, good. So that clear cytoplasm is because of glycogen. So what is the special stain done to demonstrate glycogen? Special is a special question. It comes only in special instances.
Yes.
And when it comes in special instances such as exams, you'll get special marks. Special marks is
Hey.
if you answer, good. If you don't answer, it's a very valuable part of this. Anyway, the glycogen, how do you demonstrate? By doing a simple thing called as a PS. Proteolytic acid skip reagent. So, when you do a PS and everything turns pink, it indicates that there is glycogen in the cytoplasm. And that is one of the unique features of a seminoma cell. Another thing is that these seminoma cells are separated by fibrous septae, and these fibrous septae have sprinkled with lymphocytes. So if you see sheets of seminoma cells separated by the fibrous septae, and within the fibrous septae if you see lymphocytes, it is a diagnostic of a seminoma. So that clears the microscopy and morphology. Tumor markers. It is one of the most important germ cell tumors where AFP is absent. You don't get any AFP. And what is AFP? Alpha fetoprotein.
Like I was supposed to know that,
But
but I don't.
you get other markers such as FLAP, that is placental leukocyte, alkaline phosphatase, non-specific, but still it is elevated. And another hormone called as HCG, that is human chorionic gonadotropins. So these two hormones are elevated. Any other place you get alkaline phosphatase? Any other organs?
I don't know.
Liver? Then? Only liver? Okay, you know why. Prognosis, as I told you, it is the most radiosensitive tumor. So once it becomes radiosensitive, what will be the prognosis? Good or excellent? So it is the only tumor which has an excellent prognosis. Seminoma. That is because these seminoma cells melt like cheese when you give a radiotherapy. It appears cheesy, it dissolves, it disappears. That is good for
Naturals.
doctors as well as the patients.
Oh.
Sorry, the patients as well as the doctors. Spermatocytic seminoma, as the term, it is a part of seminoma where the chromatin of the seminoma cells resembles the meiotic division of a spermatocyte. That is why it is called as spermatocytic seminoma. There are few differences from a usual seminoma, that is, it is usually seen in an age group of elderly, that is more than 60 years. And they are very slow growing and they have again a good prognosis because majority are benign. They hardly become malignant. So that's all you need to know about this one. Next, let's jump into embryonal. Embryonal constitutes, it is the second most common. It is seen in 40% of the testicular tumors. Age group is, it is less than 30 years. Seminoma is more than 30 years. Embryonal is less than 30 years. Gross. How was the seminoma on gross? Very good. So the opposite applies to embryo. What is it? Opposite? It is very irregular. It has various colors. Various colors because of hemorrhage and necrosis. And once there is various colors, we call it as variegated appearance. Variegated is various colors. And one of the most important tumor to have various colors is which one? Renal cell carcinoma. Remember, renal cell carcinomas. It is a term which is very specifically used for a renal cell carcinoma. But on cross, these are the tumors which can resemble a renal cell carcinoma. So variegated appearance is nothing but various colors. On microscopy, since it looks bad. On gross, even on microscopy, it looks bad. So whenever it is atypical, atypical is not typical. So it has pleomorphism, it has mitosis, it has high amount of anaplasias, and all these features are seen on microscopy of an embryonal cell carcinoma. Remember, these embryonal cell carcinomas still resemble the active glandular appearance. So the glandular component, that is a lumen surrounded by the cells, is always seen on microscopy in an embryonal carcinoma. Tumor markers. Which one is positive? AFP is positive and also HC. Prognosis. On gross it looks bad. Microscopy it looks worse. Prognosis will be horrible. Can't use horrible example. Put it as bad. That's embryonic. Okay, any doubts here? Am I making some sense? Some, right? When you go back home and read it, it will make a lot of sense. But make sure you read it. If you don't read it, tomorrow it will be nonsense. So make sure some sense enters into your gray matter of your brain pattern. Yolk sac. As I told you, yolk sac is also called as endodermal sinus tumor. Yolk sac is seen in a pediatric age, that is less than 5 years. It is the most common pediatric testicular tumor. Most common pediatric testicular tumor. Yolk sac, frequency is 5%, age group is less than 5 years. On gross, no, I don't have a gross of this. Anyway, you can Google it. it resembles a seminoma. It appears uniform, but only thing is that it is an embryogenic or a developing phase of a testis. So it will have what is called as a yellow tinge. So yellow-white appearance is one of the most unique gross appearance of a yolk sac tumor. So if you get a tumor with the yellow appearance in an age group of less than 5 years, is invariably a yolk sac tumor. Microscopy is important because again it has two specific features. One is what is called as the Schiller dual bodies. Schiller dual bodies. These are fancy terms which appears in fancy exams, so you can fetch fancy marks. So Schiller dual bodies are nothing but an empty space surrounded by cells. Again there is an empty space surrounded by the cells. Remember, these cells are the tumor cells. Tumor cells. So it resembles a flower. So that is why it is called as the Schiller dual body. I don't know in which language, but it is. On tumor markers, again it is positive for AFP. And one more marker is alpha-1 antitrypsin.
Long?
Prognosis is good. It has a good prognosis. So that's about yolk sac. On microscopy, apart from Schiller dual bodies, you also get what is called as the hyaline globules. Hyaline globules. Schiller dual bodies with hyaline globules are microscopic features of a yolk sac. Okay? Good, it has a good prognosis. Next, choriocarcinomas. These are very rare. But thank God it is very rare because prognosis is worse. It's horrible. The most horrible, worst prognosis, whatever you want to put out there, you can put it out. It has the worst prognosis. Choriocarcinoma is seen again in third to fifth decade, 30 to 50 years. On gross, it appears like embryonal carcinoma. It appears as much better than this. But most important thing is, it is highly hemorrhagic tumor. It is so hemorrhagic that the tumor itself can become infarcted. It becomes infarcted. Infarct is when